Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events, held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
My name is Preben, and I'm part of the GOTO team. And with me, I have Dean Wampler today. Good morning, Dean. Thanks for getting up so early to join us.
Good morning, Preben. That's not that early, so good to be here with you today.
Thank you. May I ask you maybe to do a very short presentation of yourself?
Sure. So, Dean Wampler, I work for Domino Data Lab, which is a vendor of an integrated suite of tools for data science and ML ops. I've been in the Scala community for over a decade, mostly working in the data science industry one way or the other on either the engineering side or most of the engineering side, but some data science for the last decade or so. So it's kind of a nice intersection of those two areas of interest for me being at Domino right now.
Thank you. Yes, and it's no big secret that we've known each other for some years.
Yes.
You're part of the GOTO, the wonderful GOTO community that we have in the Chicago area.
Yeah, this conference here has been great. I'll be very happy when it finally goes live again. Really miss it.
We are doing our best.
Yeah.
When we briefly talked a couple of weeks ago, you mentioned that one of the things that you're really struggling with or spending a lot of mental energy on is the gap between data science and software development. And that kind of surprised me because I heard the same story 3 years ago. Does that mean we haven't really come any further?
Yeah, I think it's going through a lot of refinement. Like the current thinking, for example, is that, the DevOps side of the software world has been very successful at solving a lot of problems to make deployments of production software easier, automated, all those things. Maybe we should do something similar on our side being the data science side. So I think if you look back a few years ago, people were sort of figuring out, all right, here's a model. I don't know how to get it into production. I don't know what to do with it after that. And so they would put it in a container and put it in production and hope for the best. And maybe start looking at some metrics to know when the model's performing well and so forth. And now we're getting to that phase of, we really need a little bit more control, more data governance, more automation, repeatability, so we can do traceability back when problems happen and so forth. So it's like anything, it's been a process of maturation. And if you go into any typical organization of data scientists and data engineers, they'll be all over the map in terms of maturity in this way too. So a lot of that is happening as well as people learn maybe what they should be doing.
So we have actually moved us those past 3-5 years. We're on a journey here. That's what you're saying.
Pretty much, yeah. As we all know, nothing happens overnight.
No, that's true. No, and how long did it take before we finally got to melt dev and ops together? I think that was a journey too, definitely.
That was, and it took something like cloud services, in very generic terms, organizations like Netflix, Google, and so forth, who realized, we never can have downtime. We have to figure out how to do this stuff live, deploying new things, keeping the site up and running. And once they figured all that out, then they found out, we don't have to do these big bang deployments anymore. We can do things incrementally, with very little impact to end users, except in good ways, new features. So I think that's where the data science world is coming into. One interesting, there's several differences. And one I'll just mention offhand is you don't necessarily deploy models over and over again really fast like you might for some applications, say daily. You typically leave a model running for a while until it's clear that it needs to be updated or something. But nevertheless, a lot of the same challenges exist in the data world, plus some new ones.
Help me. I don't really see how that can be a challenge. So you let the model run to gather experience, or if you train the model in production or whatever for some time, and then at some point maybe you train it in a test system, I don't know, then you deploy it to production at some time when you feel it's mature. How is that different from testing your software over a period and then move it to production?
Yeah, so there's certainly analogies that people are exploiting. You mentioned something that's kind of an interesting sort of smaller trend, and that is, should we train in production, or maybe have a production level pipeline, which is fully automated in the usual way that we build software now? Or should we let data scientists continue to build models sort of incrementally, iteratively in their experimental environments, and then we take that artifact, like check it into version control of some kind, and deploy that, right away? In which case, it feels a little bit more like how we do software. Well, I think we're going to get to the point where most, at least larger organizations, will decide, you know what? If we deploy a model, it's exactly the same thing as this software works on my machine. Why isn't it running in production? We really actually need to get to a maturity level where data scientists, figure out the model structure, like so-called hyperparameters, using some sort of representative data to determine this seems like a good model, and then let an automated pipeline actually build the deployable model itself. There's some other advantages to that. You can verify, that you're training at scale, whereas a data scientist might be using a smaller data set for performance reasons. If you have data governance concerns about who has access to certain data, you can hide that completely behind your pipeline of training. There's a bunch of reasons like that, but mostly it's the repeatability, the traceability aspects, where when I put a model in production, I want to know exactly how it was built, what data was used to train it, and then be able to trace back if it's problematic. Then I have a full suite of traceability artifacts that I can use to understand, or hopefully understand, why it failed. So, I think this is important. There's a lot of analogies that we can leverage in DevOps, a lot of tooling we can leverage, but there are some unique aspects, and there's a maturation process that people are figuring out what should be automated versus what is still okay to sort of like hand build.
The real problem here is that machine learning is, to some extent, a black box. You don't really know all the details inside of it.
Well, that's certainly one of the big areas of research and sort of technological innovation that's going on, so-called explainability. And this is especially problematic for very complex systems like neural networks. And it's actually an argument why a lot of people will still rely on simpler mechanisms, sort of more classic machine learning, where it's easier to understand what's going on if it's good enough for their purposes. So you see that tension a lot, where people, they see neural networks as this new, amazing, shiny thing, and they want to use it, but then they run into this problem of, how do I really understand what the model is doing? Why did it say that person shouldn't get a credit card, or that tumor was missed, or whatever, in an X-ray? So there's still a lot of those kind of things that need to be sorted out, and are being sorted out for the more sophisticated approaches. And the other reason for sticking with simpler models in a lot of cases is it's computationally easier to work with, easier to train, easier to score at runtime. So there's still a lot of tension there about optimal choices of model types and so forth.
We're on a journey here. Which tools do we have that can help us?
Yeah, that's another area where you're seeing some maturation happening in the industry. There are, for example, one of the things I think most interesting right now is the notion of a feature store, which is emerging as kind of a boundary between the data science process of ingesting data that can be in all kinds of states of quality and formats, transforming it into so-called features. Really, they're just columns with maybe more metadata attached to them. And then effectively like a database, really. And then that feature store is what is used to do model training, both for experimentation as well as production, and even in some cases actually serving the data. So if I have a raw stream of data coming in, I might pass it through this transformation process, put it in a feature store, and then let that be what is used by the production scoring system. So things like that are ways in which people are figuring out where are good boundaries between these different roles and responsibilities. What tools kind of best fit the needs on both ends of that spectrum, the producers as well as consumers. So that's one of the interesting ones, I think, for just the sort of low-level pragmatics, if you will, of turning data science and data engineering into ML ops, or whatever term you want to use. As far as some of these issues like explainability and so forth, there have been some interesting tools developed where people are learning how to analyze the impact of data changes or feature changes, if you want to use that term, and how they impact the scoring of the model, how they impact training. One of the advantages there is figuring out what features actually matter, so that if I can cut back to say 100 features versus 1,000, that's a huge energy savings and performance benefit. So there's a lot of tooling like that where sort of industry and academic research is starting to attack some of these more sophisticated problems, and then figure out how we can leverage that technology to let us use things like neural networks with more confidence.
For a moment, I was hoping that you would mention the GOTO conferences as one of those tools.
Well, actually, no, it's a really good point, because things are moving so fast. It's really hard for most people to keep up with what's actually interesting or what actually is showing promise. I try to keep up with some of the research papers, and it's just kind of hopeless for me. But yeah, I think that is really the benefit of conferences like GOTO for me, is that you can come together and not only learn what experts in your specialty are focused on and what they're figuring out, but also kind of figure out what other people are doing. And sometimes that sort of cross-pollination is hugely valuable. It's really tempting to just go to conferences that are narrowly focused on your specialty or interests. And they're good. I don't want to denigrate them in any way. But I often find that some sort of light bulb moment happens when I go to a talk that's completely outside my area of specialty and hear what people are thinking about in their context. So I think, to me, that's always been one of the great things about GOTO, is just the caliber of the sessions and the tracks in general, but also the cross-pollination that's possible.
I think you're right. Now, this should not turn into a big commercial for the GOTO conferences, that it actually was meant as a joke. But I think you're right, because I suppose, like with everything else, you need to find the flavor and the way that works for your company and for your culture. So there's no one size fits all here. So one of the best things you can do is actually to hear what worked and what didn't for other organizations, for other teams.
Yeah, and if I'm a data scientist, I kind of need to learn more about how to manage projects. So, that's something that we've gotten very good at in software, well, at least in theory. If you walk into most organizations, they still struggle. But that's the sort of thing now where you see this cross-pollination. Data scientists need to learn more about the engineering cultures that have been maturing, like DevOps, like agile methods. And similarly, data scientists data engineers need to kind of understand data better than maybe they did 10, 20 years ago.
Yeah, see, that's another point, because maybe the way we teach software development, software engineers, maybe we should realize that they have a new persona that they should work. It's not just the customer, it's not just ops, it's not just whatever. Now there's a new type of persona in the picture too.
Yes. And when you said that too, it reminded me that software itself is evolving. There's been a lot of interesting stuff said and now starting to materialize for actually using machine learning to accelerate software development. Like using GitHub's code space, I think it's called, where it actually will suggest code for you, which hopefully will go beyond just like cut and paste patterns or whatever. So I think it really is true that you can't just sit still. If you're going to get the most productivity out of your organization as a whole, you really have to understand where other people are and what their problems are and how the world is changing what matters to you, like data becoming even more important than it was in the past.
Yeah, which, by the way, GitHub's new initiative, it is definitely fascinating, but it is a little bit scary too, isn't it?
Right. Yeah, it's almost like Stack Overflow being automated. That old joke that we just spend our days Googling stuff on Stack Overflow.
Yes.
But, And even the way we learn has changed a lot. I mean, I remember, we're times in the way past, like, pre-internet, actually, when I would very carefully, record information, like I found this algorithm, or I'd buy all these books. And now it's much easier to find things when you have questions like, how do I do something? But you also have to be a savvy consumer, because there's so much, as in life in general, so much useful and not useful information out there.
That's amazing. Let's pick it up at some, hopefully soon, in-person conference somewhere. Thanks a lot for joining me today. Thank you.
Oh, it's my pleasure. Yeah, good talking with you today, Preben.
Thanks for listening to this episode of the GOTO Podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.